Okay. Oh, that's loud. Hello, everyone. My name is Marilee Karinshak. I'm an undergraduate student at Washington University in St. Louis, and I'm excited to share my team's work through the NASA Develop program, where we monitored air quality and community exposure in Hampton Roads, Virginia. So before we go any further, I want to give you all a quick crash course on important air quality terms. Particulate matter and aerosols are terms that are used to describe solid particles and liquid droplets found suspended in the air. And particulate matter is categorized by size. In our project, we specifically focused on PM 2.5, which are particles that are 2.5 microns or less. To put that in perspective, these particles are about 30 times smaller than a single strand of human hair. So they're really small, but we're able to detect them through a type of measurement called aerosol optical depth using satellites, because thicker layers of aerosols reflect more light than thin layers. And so using satellites, we can detect these differences and then determine which regions have more aerosols than others. So for this project, we focused on a region in southeastern Virginia called Hampton Roads, which is comprised of 7 independent cities and is home to over 1.7 million residents, 47% of which identify as people of color. And uniquely to Hampton Roads, it is also the location of 2 major coal facilities, which are suspected contributors of PM 2.5. Because the coal is stored in these large uncovered piles, this dust can become suspended in the air whenever the wind blows, which can become a source of major cardiovascular and respiratory health concerns. So to address this, NASA Develop partnered with the Virginia DEQ to support their ongoing Tidewater air monitoring and evaluation project, which has had some limitations due to Hampton Roads having very few ground monitors. And this makes it very difficult to understand the large spatial air quality trends, and NASA is able to use their satellites to help fill in these data gaps. So in order to do this, I want to introduce you all to the NASA Earth observing fleet that we used. We used 3 satellites, the MODIS sensor from the Aqua and Terra satellites, and we also used the CALIPSO CALIOP satellite to understand the vertical distribution of pollutants. So first, we started off with the MODIS sensor to get an understanding of the horizontal distribution of aerosols across our entire 10-year study period. So here, the yellow color represents higher levels of aerosols and the purple represents the lower levels. And as you can see, our more urban regions have the higher concentrations of aerosols, as well as the coast. And notably, northern Norfolk and southern Newport News are also the locations of the 2 major coal facilities, which could be contributing to these higher aerosol concentrations. Conversely, the lowest levels are found over the Great Dismal Swamp, which is a protected area with almost no human development, so this would be expected. So now, to show the variation over time, we made a time series analysis to show how these spatial distributions shift from year to year. So you'll notice that there is some crazy variation, specifically for 2021 and 2023, and those were years that experienced wildfires. However, if you look at the broader spatial trends, they stay about the same, with northern Norfolk and southern Newport News having those higher levels of aerosols from year to year. And this is all very helpful and was already a big step in the right direction for the Virginia DEQ, because they now had an understanding of larger spatial trends, but we wanted to ensure that this would be understandable for an average person living in Hampton Roads. So we converted it to the AQI index, which is a common tool that the government uses to communicate air quality and something that residents likely have some familiarity with. And as you can see, this again is from the 10-year study period, and we see the similar trends of the more urban areas having those higher levels of aerosols and the Great Dismal Swamp having less. And again, we showed the variation from year to year, with 2021 and 2023 experiencing worse air quality because of wildfires, but overall, we see the same spatial trends. But it's important to note that over our entire study period, there was not a single moment where the air quality exceeded the threshold to be considered unhealthy for sensitive groups, which means that at least in terms of PM 2.5 and AOD, that Hampton Roads' air is quite clean. But so far, we've only had a horizontal understanding of air quality. And we want to understand if the aerosols that are being detected are near the ground level, because that is where it's most likely to impact human health. And so that's where we brought in the CALIPSO satellite, which takes vertical slices of the atmosphere to then determine which aerosols there are and where they're being detected and what altitudes they're at. So we specifically focused on Hampton roads and looked at the CALIPSO paths that intersected with this region to then use them as case studies to see if our MODIS readings were picking up aerosols near the ground level. So here is what we call a vertical feature mask. It's a little overwhelming. There's a lot going on. So we're just going to focus on this red box, which is focusing on Hampton roads. So as you can see, this is showing the different subtypes of the aerosols that are found. And on this day, CALIPSO was finding over the coal facility that there was polluted continental and polluted dust aerosols. Then if we zoom in on the MODIS imagery, which is right here, and zoom in on that coal facility, which is about right here, we can also see that MODIS is also picking up on those aerosols that are located near the ground. And then for a even deeper look, we have what's here called an extinction coefficient plot, which measures the amount of aerosols and where they're located at specific altitudes. And higher extinction coefficients mean that there are higher levels of aerosols. And the big takeaway here is that from this extinction coefficient plot, all of the aerosols that were being detected were found within 1 kilometer of the ground, meaning that these would be at risk for people inhaling them and then potentially developing those health concerns. So how can we use this to support decision making? It's very helpful for the Virginia DEQ, but they also want to impact the people living in this region. So they specifically wanted to focus on environmental justice communities who were also experiencing higher levels of aerosol exposure. And so to help them prioritize their resources, we made a social vulnerability map. So the blue axis is social vulnerability, which we categorized based on the Virginia DEQ's definition, which is based off of Virginia state law. And then the red axis is the average amount of aerosols over that area. And then this brown color in the upper right is where these two intersect, meaning that a community is highly socially vulnerable and has higher risk of AOD levels. And here, again, are where these coal facilities are. And as you can see, there's some of those higher at-risk communities that are also near those coal facilities. But while we weren't able to determine whether these coal facilities were directly causing these AOD level increases, we were still able to help the Virginia DEQ prioritize their resources to maybe put in more air monitors, help fill in the data gaps here, and then get a more holistic understanding of the air pollution dynamics in this region. And it's important to note that NASA Develop has actually continued its partnership with the Virginia DEQ. They are currently using other satellites and analyses to better understand the air pollution dynamics and see what these pollutants are and where they're coming from. And so this was really an important step to helping them begin to understand these dynamics. And I'm very proud to have been a part of a project that's directly impacting people's health in this region. So I would like to thank my collaborators on this project, Brooklyn Appling, Sydney Hipp, and Piper Coleman, as well as our wonderful science advisors, Dr. Sai, who's in the audience right now, and Dr. Travis Toth, and of course, our wonderful partners at the Virginia DEQ and the wonderful project support from the NASA Develop staff, including Olivia, Marissa, and Amanda. And of course, thank you to AGU for making this experience possible. I'm very glad I was able to share some of our project's impacts and be inspired from all the people around me. So here's my contact information. Feel free to reach out if you have any questions. My LinkedIn, shameless plug, feel free to scan. And thank you all so much for listening.